Good morning to all of you. Last week we saw what threads are and how to create threads and how to synchronize them. Just to recap what we did last time, I'll quickly demonstrate the use of threads with a new example. Let us say you want to run through two threads. One thread will display one message and another thread tries to display another message. This time I'm not going to display the whole message at a time, but I will make the thread to display one character at a time. So we need to write one function, void char at a time. You can give any name and let the message received from each of the thread be MSG. So what I'm going to do here is I'm going to set up a for loop. I equal to 0, I less than message dot length, I plus plus, and I'm going to send one character at a time. So I'm going to use msg dot at I and leave little bit space and end it. Maybe you can put one cout here, end it. So I'm going to start two threads here. So thread T1, its function will be char at a time, and you can pass an argument to this. Let's say hello world. Similarly, I can have one more thread T2 and char at a time, and this is going to be goodbye world. Okay, so as I mentioned to you, threads are lightweight processes which will execute within the same process space as main thread. So when you run main program, it is one thread. Now you are creating two execution paths within this, and this main thread can make the two threads join it, and you can execute a join here so that the main thread waits until both the threads end. So after displaying their respective messages, they will come back to main, and main can terminate. So here you can say main terminated or terminating. So these functions which you pass to the threads, they are called handler functions. So the functions will be executed within the thread space. So both the threads will run concurrently and they try to compete and try to put out their message on the screen. So you will see the output sent by these two threads will be jumbled up. So now if I run the program, it will show some warning here, and you will see the output is jumbled up. So H is coming from the first thread, immediately it will shift to the second thread, the G is coming from the second thread, and again it will switch back to the first thread, and the E will come from the first thread, and then again OO from second thread will come, then again L will come from first thread, like this. So you see that since there is a common resource, that is the terminal is common to both the threads, both will try to put their messages or characters at a time on the screen. So you will not see any meaningful output coming up, all data will be mixed up. If you want to synchronize the two, that is the first thread should complete before the second one can start, then you can use a mutex. Okay, so mutex is a mechanism in C++ using which you can create a mutex variable like this, and you have to use a lock. So there are different types of locks we shall see. There is a lock type called lock guard, and here you have to specify this is of type mutex, and you can say lock mtx. Okay. Now this lock guard, it should not be put in the main, it should be in the handler function here, so that any thread enters this will lock other threads from executing the for loop. Okay, so now with this mutex variable or the lock, the terminal will be locked for one thread, and until the thread completes, the second thread will not run. So now you see hello world is completed by the first thread, and then goodbye world will come. Okay, so did you understand how the synchronization has to be done using the lock? Hello?
Sir, is there a way that if we have two functions and on both function if we define a lock guard, which one takes the precedence?
Okay, then we have to work with priorities. Okay, so here the same function is executing. Okay, now both the threads will compete with each other. Now whichever thread gets the lock first, it will execute. Okay, but if you want to make second thread to have priority over the first one, then you have to use lock. The thread priorities. Okay, so I'll take up that example immediately. So this part you understood, right?
Yes, sir. This is
okay. Okay, now coming back to priorities, you can set priorities. Yeah.
Is there any other way other than mutex to lock the particular thread? Meaning, in C we can say that there is a mutex and one more is the signal handling, meaning signaling kind of thing, right?
Yeah.
So, in here as well, other than mutex, is there any other?
Maybe there could be other ways to synchronize the two processes. Okay.
Yeah.
Mutex is the simplest way to understand also and also implement. So that's why I have just explored this part.
Sure.
Yeah. Okay. Now coming to thread priorities, there is no built-in mechanism in the thread library to handle the priorities. You have to take help of the operating system, because operating system will decide which process will go for execution, or within the process which thread will be scheduled for execution is decided by the operating system. So what I have done here is I have two tasks, task 1 and task 2. Each of these tasks will be run by different threads. So as you can see, thread T1 is running task 1, which where I am saying just say I am task 1 and sleeping for 2 seconds, and second is another task. You can execute this sleep method here also. Okay, so and then the task 2 will be scheduled, but you can set the priorities like this. So there are different priority levels. So thread priority normal is every thread will have equal priority, and if you say thread priority highest, this will have higher priority. Okay, and thread priority lowest means it will have lowest priority. So if you have normal and highest, the highest priority will be scheduled first, that is thread 2 will run ahead of thread 1. Okay, now since I am taking help of the operating system, I have to use what is called as a handle. This handle is nothing but a generic pointer which can point to your thread. Okay, thread is basically a lightweight process. So this syntax is coming from the Windows operating system. Okay, so the handle generic pointer will now point to.
In the case of Linux as well, we can use the same handle, right? Or is there any
other? There you have to use POSIX.
POSIX. Okay.
Yeah. Okay. So POSIX generic pointer will be there. That you have to use. It is Windows specific. What I am demonstrating is Windows specific. Okay.
So
because
in case of Mac, there will be POSIX. Okay.
Yeah, POSIX. Now there is a set thread priority function which is part of the Windows library, which you have to call, and it requires the first argument to be handle type. That is why I am saying handle as thread 1, and I am typecasting this to handle. As you can see, within opening closing bracket handle, this will typecast the thread to the handle type, and that becomes available to your set priority. And there's a second argument, you have to say thread priority normal, and for the second thread, the thread priority can be again normal or highest or lowest, whichever you want. Okay, the other part of the syntax remains the same, T1 join and T2 join. Okay, now this is the way to set the priorities, but there is a small catch here. We shall see what happens when I do this. As expected, thread 2 should run first, right? Or task 2 should run first. See, again, I am task 1 is running first. Okay, that is problem is when you say set,
Called.
yeah,
Yeah,
when you say set thread priority, thread 1 has already started. Okay, and it will execute and complete, and after that you are setting priority for thread 2. So by the time priority of thread 2 is set, thread 1 is already over. Okay, now if you want to see the difference between the two, in this task 1 you have to set up one large loop here. Maybe you can say here, you can say for int I equal to 0, I less than some large number, I plus plus, and then see out it. Instead of just printing this, so that task 1 is continuing, and after some time when task 2 gets the priority, it will also, you will see that the task 2 will get executed before the completion of task 1. So here also if you set up a loop,
So instead of calling task 2, then you just call task 1 itself. So that
Yeah,
at that particular point of time, how it will be.
no, that obviously if you set task 1 higher priority, it will execute.
Okay.
Okay, but what I want to see is I am setting priority of second thread to higher.
Yeah.
So that should get preference in counting. For example, here it is counting up to, let's say, 20,000 or whatever. So the what is coming from thread 2 should execute first.
Can you name task 2 and task 2 command so that it will not be jumbled?
Yeah, I mean, what I can do is I can start this from, let us say, 1000 whatever, and go up to some large number like this.
Yeah, definitely.
So here hopefully you will see priorities given to thread 2. Yeah, but you cannot make out. You have to introduce delay and see what is happening. Okay, so you will see that thread 2 will be given preference. Its count will complete, and then thread 1 will continue.
Okay.
Okay. So in this process, if you see, thread 2 is already complete somewhere down here, 718 or something like that, and then the thread 1 will continue. Okay, so some delay you have to introduce to see that effect coming through. Okay, so priority can be set using the Windows library. So that's why you see here I have included #include windows.h. So this library has support for the defining the handles and also the two functions, set thread priority and the constant which are used here, thread priority normal and thread priority highest. Okay.
Usually the header files in the include we will not give the dot h. So why?
Yeah. Now,
over here?
see, in C++, there is that .h is taken away, but this Windows .h, it is of C program.
Okay.
That is why that .h is coming.
Okay.
Okay. Yeah. Alright. So setting priority, there is a provision, and you should take help of the operating system support and set the priority so that whichever thread you want to run first, that gets the priority. Alright. Okay. Now threads, when you use as I told you, you have to use log to synchronize the processes. But there is one peculiar problem which you encounter, which is called as producer consumer problem, which you might have learnt in your operating system. Okay, so let me show you what is that producer consumer problem and how I can write a C++ program using threads to solve this issue. Okay, is my screen visible? Okay, now assume that we have a queue here and its size is set to 5. It means you can write 5 data items into this queue. And queue, you know, it is first in, first out, right?
First in, first out.
Okay. So there is a thread P1 which is a producer. Okay. So this producer will add data to this queue one at a time. Let us say it's just putting some integer value here. Whatever value may be, it can be 1, 2, 3 like this. So as long as there is space, it can write to the queue. But what happens when the queue is full? The producer cannot write, right? So it has to wait until the queue becomes empty. And at the other end of the queue, there is a consumer. There is another thread which will consume this data. It will read data from here until the queue becomes empty. At least one data item is read and there is room for another data item to be written. The producer has to simply wait. Okay. So how do producer and consumer coordinate among themselves so that producer does not write when the queue is full and consumer will not read when the queue is empty? Okay. So do you see this is a problem of some importance?
Yeah. Because queue is itself is a resource.
It's a common resource which both are sharing. Okay. So there should be proper coordination among the consumer and the producer so that the producer will put the data when the queue is empty or partly empty and consumer will consume the data when there is enough data to be consumed. Okay. And this kind of a scenario exists in networking. Okay. So you know that network protocol stack, you are aware, right? TCP, IP, isn't it?
UDP.
Yeah. So whatever is that stack. So the server will be writing packets to the buffer. Okay. This is a server which is writing data to the buffer and the network card will be sending data out onto the network. So both have to agree on to some protocol and use this mechanism to send out the packets which are sent by the server onto the network. Similarly, when the data arrives from the network, the server should know when to read the packets which are arriving. Okay. So this is a practical problem which need to be solved using proper synchronization between the producer and the consumer. So let's see the usage of this example with an example. Now before that, as I told you, we have to use locking mechanism to synchronize the two processes. There are, in fact, I have shown you only one type, one lock, that is lock guard. In fact, there are 5 different types of locks. So let's see each one of these. So lock guard is the simplest type of lock. When you say lock, the mutex will lock the process and you don't have to unlock it manually. It unlocks automatically when the mutex variable goes out of scope. Okay, so this is what I demonstrated you in the example of caret time. Now, if you want to lock and unlock yourself manually, then unique lock is to be used. So this is another type of lock, right, where you can manually lock and manually unlock. You don't want to wait until the variable goes out of scope. Okay, so we'll see in producer consumer problem, we'll be making use of this kind of a lock, that is unique lock. Then third one is scoped lock. This is same as lock guard, but you can specify more than one mutex variable in the lock. In my previous example, I just said lock mtx. If you have two mutex variable mtx1 and mtx2, I can say lock just 1 minute. if I'm using a scoped lock, in the lock function I can say mtx1 comma mtx2. So both the locks will be locked with a single lock function. So that is what this scoped lock will do. Again, when the variables go out of scope, they get unlocked automatically. Then there is a fourth type of lock called shared lock. It allows shared read. That is, even if there is a lock, if a thread is reading the data, two threads can enter and read the data. But if it is exclusive, whenever one of the thread wants to write, that time it will be exclusive. It will not allow any other thread to enter the functional block. Okay, so this is useful to improve the the responsiveness of the threads. That is because when you are reading, there is no problem reading a shared resource, because you're just reading the value, you are not modifying the value, right? So you need to put the lock only when there is a write operation done by one of the threads. Okay, so shared lock is useful to improve the responsiveness. And then we have a timed mutex. That is, you don't want to wait indefinitely. You want to try to lock the resource for a certain time, and within that time, if you get a lock, you can proceed. Otherwise, you can just come out of it and try at a later time. So this is useful where again you don't want a thread to indefinitely wait, because it has other important tasks to be performed. Okay, so this again improves the responsiveness of the threads, right? So,
and you can use it for round robin kind of thing.
Yeah, that's right. So now let us see how to build this producer consumer problem. Now here we have to use what is called as a condition variable. So there is again a library for that, #include condition underscore variable. Now this condition variable allow you to notify the other process that something is available or something is not available. For example, you want to notify to the consumer that the queue is full. Consumer can wake up and consume the data. Similarly, the consumer can notify the producer that something is empty, that is the queue is empty. Okay, so there are two variables which you need to define: condition variable,
and we can
semi.
also say that the data is there, meaning it is not empty, it is not full, but some data is there.
Yeah, some data is there. Yeah. Okay. Yeah. So for this, I'll be using the standard template library queue of type int, and I name it as buffer. So in this buffer, I am going to push data using the producer, and in the consumer, I am going to pop the data from the queue. Okay, and I'm using a single mutex variable mtx. Now within this producer, what I have to do is I have to continuously run this. So I put a while true. It means this is going to be a never-ending process. That is why manual unlocking is required. So what I have to do is, first thing is I have to, within the producer, I have to put a lock. So I use that unique lock. I have to notify to the consumer if at all the queue is partly full. So I have to wait until some data is put into it. So there is you mention what lock you are using, and here you write a lambda function.
The parameter.
Yeah. See, you have to write what is called as a predicate. So the second part is called as predicate. This predicate will return true or false. So you have to check buffer dot size is less than max buffer size. So I have defined max buffer size as 5 here. If you notice, it means as long as it is still not full, okay, this will keep writing data to the buffer. So this is wait until predicate is true. So what happens now? Buffer size is less than max buffer size. So it will be true here, and the control will see out. Now you want to know whether it is coming from producer or consumer. So I can say producer ID. I'm just getting one argument, producer ID. As you can see, within the producer function there is a producer ID which I will display here. So you know who is putting out the data on the right, produced value. So value is initially 0, and after you put out this message, you can buffer dot push value plus plus. So I'm pushing the value into the CV notify. I have to notify the consumer, and this log the consumer can read it, and if you want you can wait for some time. So where we have a sleep for function, package name is called chrono. Chrono in Greek means time. So here you can specify in millisecond for how long the thread has to wait. Let us say 1000 milliseconds means 1 second it will wait. So this is what the consumer will do. Okay, so it will keep putting data into the buffer. As long as buffer there is enough space, it will be going here and pushing some data and printing that it has pushed this data, and keep notifying the consumer. And once this buffer is full, that is buffer size greater than or equal to max size, it will wait here. Okay, do you see this function, how it is, when will it wait?
Yeah.
Okay.
It is waiting once if the condition is false.
False,
that
yeah. Condition is false. Moment condition becomes false, that is when buffer size equal to max buffer size or greater, it will not become greater. When it becomes equal to, it means there is not enough space. So it will wait here. It will not try to write something. Okay. And by then it would have notified the consumer many times over. And if the consumer is alert, it will wake up and consume that data. Now within this consumer...
Sir, one question.
Yeah.
And if you don't notify, meaning the consumer will say that, here it makes more sense when the data is empty, meaning the consumer will not be reading if the data is empty.
Yeah.
But in case of producer will not write when the data is more than or equal to buffer size.
Yeah.
Right? So if some data is there, meaning at least if some particular one data is there,
Yeah.
then the consumer should be notified that the data is there.
Yeah, I mean that is what is happening here. See,
Okay.
it will not wait indefinitely. No, buffer size initial is what, 0.
0.
It will come here. It will push one data and notify it to the consumer.
Okay.
And after unlocking, it will go back and again check if the buffer size, now it is 1 less than buffer size. Again it will enter and it will push one more.
Right.
This will be going on until it writes 5 data items, and once it is 6th, it will wait. By then consumer might have consumed 2, 3. Again it will will not wait. It will go into this block and keep doing this. And here again it has to get the lock, unique lock, text lock ntx. It gets the lock, and then here cv empty lock. Here again we have a lambda function within the body, return buffer dot empty.
Buffer dot size is equal to 0.
Yeah. So wait until buffer not empty.
This is equal to
Yeah. Now at least one data return, buffer empty will be false, and this will return true, and it will continue like this. Okay. You can say cout consumer ID, whatever is your consumer ID. Say consumed value. Okay. So I have to take one variable here. So before I print out the consumed value, I have to consume that value. So I declare int item equal to buffer dot front. You have to pop that value so that it is removed from the queue, right? cvmt dot notify, and this lock I have to unlock. So this notification and unlocking can be done after displaying. Again here chrono millisecond. You can introduce less delay here. Okay, so now that producer and consumers are ready, you have to create 2 threads. So here you say thread producer T1, and within this you say producer, let us say 100 is the producer ID. So the second argument will go as an argument of the function consumer here. So if you observe, producer int producer id, whatever this prod id which I have given here, that will receive this 100 value. Okay, so this is my first thread. Then second is your consumer, and you have to pass consumer here, and let's say its id is 200, and as usual producer will join. It means the main thread will wait for both the. So what should happen is the producer keep producing data, consumer keep producing, keep consuming the data. So let's see whether that is happening.
I think we are not giving the values.
Yeah. See, as you can see, initial value is 0, then 2, 3, 4, it is going on. No? Okay, so whatever is produced by the producer is consumed by the consumer. So 14, 15 is produced and it is consumed, 17 is produced, it is consumed. So like that, both are synchronizing among themselves.
Can you just go a little bit about what is the value, how we are?
Yeah, value is just one variable which is initially 0. Okay, so that is within the loop it is getting incremented, no, here.
Oh, okay, buffer threshold.
Yeah.
And in the consumer,
consumer, that value is received in this item,
and then we are
displaying that with the consumer ID.
Okay.
See, whatever value producer is producing is captured by the consumer and it is displayed. That's the only thing. Okay, so would you like to try this out, or it's okay if I share the source code with you? You can see later.
I would like to try, but
yeah, it's a bit lengthy. So what you can do is go through this code again. I will share the source code with you. Okay, so just you need to understand that it is coordination among the two threads. Now, question is, can more threads participate in the same queue? Definitely yes. I can put one more thread here, P2. Okay, again producing the data. Now you see this 101 is also adding its own data.
And how to come out, sir? Is there any,
you can put a break there. You say if the value reaches some 50 or whatever, you can break. Okay. So
we can add that connection.
Yeah, you can add that. Similarly, I can add a separate consumer here. This is 201. So there are two producers and two consumers now. And of course, they also have to be joined here. If you want to break, no, this loop has to be broken. So here you check after this delay in the producer, if value greater than, let us say 50, you can say break. So after after 50, now it is, see, it is going indefinitely. You have to break this. Okay, so once you reach 50, you will come out. Similarly, here item value you can check.
And one technique.
Yeah,
empty.
If item or you can say buffer empty, you can break. Okay, if buffer dot empty, you can break here. Okay, so now if you run, so the producer consumers will execute concurrently and will break. So 1, 2, 3, it will go on up to 50 and then it will break. Now there is a lot of delay because more threads are involved. No? So it will take longer to continue.
Maybe reduce the delay in the producer, maybe it will be faster.
Yeah, no, it got stuck somewhere. I think so. Let me remove this. Let us see. Permission denied.
No, it was getting used, right? So that is why. There is one error also. That is one error. There is one error. It is showing there is one.
Is there an error somewhere? No, let me just 1 minute. Let me check again. Because the previous producer consumer was running, so that is why it. Yeah, now it is going. That's going fine. It will break after 50.
Producer will break, but consumer will not.
Yeah, consumer will keep waiting until buffer becomes full. So that we need to some more break it here. We'll see how to do that. At least up to 50, the producer will stop. Okay. You should have given a smaller value.
No problem.
So, if you are working on any operating system related programs, invariably you will see this producer consumer problem, and there will be programs of this kind. Okay. So, after 4950, the producer stopped. Okay, and the consumer also stopped. It is just waiting. Consumer has not exited. Producer has exited. Okay. The consumer, we have to put some condition to exit. Maybe.
Sir, in this case, you just take out the one of the consumer. Okay. So that producer will keep on writing the data. Okay. But you have to reduce the producer's milliseconds to some 100, so that C1 will keep on consuming.
Oh, okay. So you just try those things out. I'll share the code with you and experience for yourself how the whole thing is working. All right?
Yeah.
Okay. Now, what I wanted to cover a little more today is about file support in C++. We already seen this in C, but in C++, the syntax is little different. Okay. So suppose you want to open a file, then you have to open the file for write and open the file for read, and there are two streams available, F stream, IF stream and OF stream. Suppose you want to write something to the file, you have to use what is called as OF stream. And within this, let us say you want to test.txt. Let me write text2 because I have already used test1 and test. Okay, so once the file is opened, okay, it is open for output mode, you can write to this. Just as you would write to cout, you say hello world here. You can put /n so that it goes to the next line, and OFS. So just as you would write to cout, you write to these output file streams. That's it. And then at the end, you have to close the file.
And what is the mode of writing?
If you want, you can make it append mode. So there is a way to mention that. Just app, I think so. syntax is like app means append, otherwise it will be write. Okay, so if it is output stream, we can only write to overwrite the existing contents or append it. Now if I run the program, now let me put one cout here. And if the file does not exist, it will create one and append to that file. Okay, now that file will be in test2. Where is test2? Yeah, in this folder, in the output. We have written it correctly. OFS string.
Maybe refresh the left external search. Maybe it will appear. Refresh the.
Pardon me?
Refresh button at the top of the Explorer.
Okay, let me check once again. Yeah, now contents written has come. Where is that file stored? Yeah, test2, yeah. Hello world, and this file, this is a file. Okay, if I run again, the contents will be appended. Same thing will come once again. Okay. Because you are opening that file in the append mode. Now if you go and check, this is appended. Okay, and if you want to read from the file and display, you can use ifstream. Okay, so let's see how we can do that. Ifstream ifs test2.txt. ifs.close. Now to read, you have to use fgetS. So you have to take read one line at a time. So you can say while ifs get line ifs comma line cout line. So until you reach the end of the file, you keep reading and close the file once you. Okay, so the same contents are ready, right? And if you want to do both read and write simultaneously with single thing, just you have to use fstream, where you can write also and read from the same file. Okay.
In this case, you should be very careful about where the particular cursor is.
Yeah,
correct?
yeah.
If it is in the position of read, after that, whatever that.
Yeah, after writing, you have to use seek function to reset it to the beginning of the file and then read. Yeah. Okay, so that part you explore. I will give an assignment where you use fstream to open a file for write and use fseek to position it to the beginning of the file and read it and display. So any questions here? What remains to be covered is what are called as smart pointers. That's a new concept, and they are very useful when you are doing type conversion. And there is a safer way of using conversions from one type to another. Okay, and we shall see static casting, dynamic casting, and all those things. Okay. So that is the only last part that is remaining in C++, which we shall take up on Monday. Fine. So I'll share.
Can you share both the source code, sir?
Yeah, I'll share all the programs with you and give one assignment which will cover all these things. All right.